Hey, this is video number 2 for integrated 2. I'm actually going to write flowchart proofs for congruent triangles. And we're going to start, or I'll have kind of a variety of questions. Some questions are a little bit easier, some that are a little bit more complicated. We'll start with the one that is hands down, I believe, probably the most straightforward. Now, the given information is in the picture itself. So the first thing that you always want to do, or I highly recommend that you do, is figure out what your given information is and get it in the proof. Now, the given information might be written out in words for you. The given information might be some numbers that are given to you. The given information might be congruent markers inside the picture. It depends. So if I take a look at this picture itself, I see angle markers. I see this bottom portion of angle S. I'm not going to call it angle S. There's too many angle S's there. And this top portion of angle S. I know that they're congruent because they used a single tick mark in that corner. That's given to me. I don't have to do any work for that. So I'm going to go ahead and set up. You can do bubbles or boxes. It's up to you. I know that I want to do that bottom part of angle S. All right, you got to be super careful with this. So what I'm going to do is I'm going to start at angle S itself. I'm only going to do the bottom one right now. We want S to be in the middle of the name because that's where the angle is located. Now I want to do the bottom one. So what I'm going to do is I'm going to start at angle S and I'm going to kind of trace out the two line segments that trap angle S. So when I name this, I'm going to call it, I'm going to leave some space here for the first one. I need S to be in the middle of the name. The other two, so where the line segments end, R and U, those are going to be the letters that surround this. So RSU, all right, is congruent to. All right, now I want to do the other one. Now I know, so going back to my picture, I want to do the other part of S. Trace the line segments out so I know how to name this thing. S needs to be in the middle of the name. So angle, S in the middle of the name, and then the ends of the line segment. So T and U. And I know that these are congruent because it's been given to me. So here we start building our proof. So inside the box is the congruence statement or the given, whatever it is that you have from the proof, and then your reason goes outside of the box. Okay, that covers the blue angle where the S's are located. And I cannot call it angle S because there's too many angle S's to choose from. Okay, taking a look, it looks like we also have another angle down here in the bottom. I know that they're congruent because they have the same markers in them. So I'm going to do the exact same thing. So I'm going to do the bottom angle first. So I know angle, make sure the U is in the middle, trace out to the corners. So I'm going to say angle RUS is congruent to angle. Okay, let's do the top one now. U's in the middle of the name, trace out to the corners. So let's do SUT. And I know that these are congruent, once again, because it is given to me. It was already in the picture. It wasn't something that I had to come up with. Okay, I have exhausted the given statements. There's really nothing else that I can say based off of the markers in the picture. Now it's up to me to figure out what actually is also congruent. So if you take a look at the picture, we typically look for vertical angles or we look for reflexive, either angles or sides. In this case, I've got this whole top triangle, bottom triangle business, and this line segment SU is connecting both of them together. So it belongs in both triangles. So I'm gonna say line segment SU. I need to say, well, I've got SU in the top and SU in the bottom. I have to basically introduce it for both triangles. Since it belongs in both of them simultaneously, I'm going to say that this is reflexive. And then from here, you have to have 3 congruence statements. So look inside your boxes or bubbles. A congruent statement, a congruent statement, a congruent statement. Good, you've got the minimum. Now let's make sure we have enough information to actually prove this. So remember that you have 5 different congruences this could be. Going back to video number 1. If we take a look at this, it looks like we have angle side angle congruence. So we're going to talk about the triangles now. And you can actually just use the name that was given to you, SUR, congruent to SUT. Reason, angle, side, angle, congruence. Now, it is a flow chart, so you need to make sure that you actually show that the bubbles that were used, which was all of them, actually flows down to prove your final bubble or to get to your final bubble. Okay, moving on. And we have proofs that are a little bit more challenging here as we go. But the idea is start with your given statement. So my given is in words this time. So I'm just going to go ahead and write it out. So Fi and EH bisect each other. I know this because it was given to me. It wasn't anything I had to come up with. But now I want to be able to use that vocabulary word to actually be able to write a congruent statement, maybe a couple of them. So if Fi and EH both bisect each other, and bisect means to cut in half, so that means that Fi cuts EH in half. All right, if Fi cuts EH in half, I'm over at my picture, then that means this whole EH, where it hits Fi, that's going to be split into two congruent parts. So from this, because of bisect, I think I can say that line segment EG and GH must be congruent. So EG must be congruent to GH. I know this because I was told that they bisected each other. So this is definition of bisect. That stems from that bubble. Okay, but that's Fi cutting EH in half, but it says they bisect each other. So I think that means that EH also bisects Fi. So back to the picture. So if I take this Fi line segment and I find out where they hit each other, those guys are also cut in half. So I've got FG and GI. So FG is congruent to GI. Reason? Well, still has to do with the bubble above. This is definition of bisect. All right, I'm doing pretty good. If you take a look at the picture, we have two pairs of congruent markers, and we also have two bubbles with congruent signs. If you take a look back at the given statement, this whole bisect business, I don't think there's anything else that we could actually say. So back to the picture. Now is when we look to see if we can find any information about vertical angles or reflexive. I have vertical angles right at G. So I know, and I want to stay inside the triangles here. So I've got this angle G and that angle G. I can't call it angle G. There's too many angle Gs. So let's name the angle G on the left-hand side. So I want G to be in the middle of the name, because that's where the vertex is. Trace out to the edges. I think I'm going to do E, G, F. So angle E, G, F is going to be congruent to, okay, let's do the other side. E, G, F, I think is H, G, I. Make sure the G's in the middle. It's where the vertex is. This, I could have said first. I didn't even need the given statement for this. So don't have an arrow coming off of that bubble. And then this is vertical angles. Okay, take a look at your bubbles. We've got 1, 2, 3 congruent symbols. This is good. Take a look at the picture itself. Do I have enough information to actually prove that those two triangles are congruent? Yes, I do. I have side, angle, side. So let's go ahead and write our final statement about our triangle. So we've got triangle, and I may as well just use the name that was given to me, E, G, F. It's congruent to triangle, H, G, I. Make sure that your reason goes on the outside, and this is side angle side congruence. And the only way we got here was because of all of the bubbles above. So make sure that they're included and flowed down. Okay, let's move on.